What is time?
A deceptively simple question, yet it is the key to understanding relativity. Is time universal? In other words, is there an audible tick-tock throughout the galaxy? The answer, my friends, is no.
Was Albert Einstein right when he predicted we would never be able to see the true beginning of the universe? The James Webb Space Telescope has now observed something profound in the extremely early cosmos that might just confirm his century-old prediction. But what are we really seeing here? Is it a strange and shocking void, or could it be the very edge of time itself? Imagine for a moment how 100 years ago scientists slowly began to look beyond the confines of our own Milky Way. What they saw astonished them. At first, it was just hazy nebulae. Then it became clear these were entire other galaxies. This all took place slightly after Albert Einstein presented his theories of relativity, and these new discoveries seemed to confirm many of his purely theoretical predictions. However, Einstein remained unsure about one key question, whether the universe truly had a beginning. But on a related point, he was certain. He was convinced that even if the universe did have a beginning, we would never be able to see it, no matter how powerful our telescopes became. Now, Webb may have proven him right by finding a vast emptiness at the very limit of its vision. But what if that emptiness isn't a failure to find something? What if the emptiness is the discovery? So how did Einstein come up with this crazy idea? It was a profound consideration that stemmed from his theory of general relativity. When he applied his equations to the universe as a whole, they revealed something unsettling. The cosmos could not be static. It had to be expanding or contracting. This simple mathematical truth led to a staggering implication. If the universe is expanding, then in the past it must have been smaller. If you rewind the clock far enough, everything must have originated from a single point, a singularity. But Einstein also gave two interesting reasons why we could never directly observe this absolute beginning. Firstly, the theory suggested a period immediately after the Big Bang where the universe was a hot, dense fog of hydrogen gas. For hundreds of thousands of years, no stars had yet ignited. Scientists today call this the cosmic dark ages. So the question arises, how could we possibly see an event with telescopes if for a long time after there was no light to see? And secondly, and more fundamentally, he believed the beginning would move further and further away from us due to the constant expansion of space and would therefore be out of our range of vision, so to speak. The very laws of physics break down at a singularity, representing a kind of horizon that will forever obscure our view. For the rest of his life, he was convinced that no matter how good our telescopes were, the absolute beginning would remain hidden. For 100 years, this was a theoretical debate, but now the James Webb Space Telescope has journeyed to that distant edge of time. The James Webb Space Telescope isn't just an observatory, it's a time machine. Because light travels at a finite speed, looking at distant objects is the same as looking into the past. Webb, with its enormous golden mirror and incredible infrared sensitivity, was designed to capture light that has been traveling for over 13.5 billion years. As this ancient light travels across the expanding universe, its wavelength gets stretched into the infrared spectrum, a phenomenon called redshift. The higher the redshift, the further back in time we are looking. Its mission was to push past where Hubble left off, to witness the universe's infancy and find the very first galaxies. These first structures would be the key to understanding everything that came after: how galaxies formed, how they grew, and where the supermassive black holes at their centers came from. Theories and simulations predicted Webb would find small, faint, fledgling galaxies, but when the first images came back, the scientific community was stunned. The predictions were wrong. I'm sure you've heard that the JWST has discovered an extremely large number of very old galaxies. Instead of a quiet cosmic nursery, Webb found a universe that was already a bustling metropolis. The data revealed galaxies that were far brighter, more massive, and more structured than any model predicted should exist so early. One of the most staggering examples is a galaxy named Jade's GS-Z14-0, seen as it was less than 300 million years after the Big Bang. It is bafflingly large and luminous, not because of a quasar, but because of an immense population of young stars. This implies nature somehow formed a structure with the mass of hundreds of millions of suns in an impossibly short amount of time. And it wasn't an isolated case. Webb has found that these surprisingly mature galaxies are far more common than scientists expected. It's as if you walked into what you thought was a newborn's nursery and found it filled with fully grown adults. This discovery suggests the process of galaxy formation was far more rapid and efficient than we ever imagined. The universe wasn't slowly waking up, it was born in a sprint. But this surprising abundance created a new, deeper question. If the universe was so full, so fast, what happens when Webb pushes even further, to the absolute edge of observation? And this is where the second discovery comes in. This is where Webb found the emptiness. As Webb strains its senses to their absolute limit, it's beginning to reach a boundary, a wall in time. It is peering so far back that it's approaching the very epoch Einstein spoke of, the cosmic dark ages. This is the period before the first stars ignited, when the universe was filled with a uniform, opaque fog of neutral hydrogen gas. What Webb is observing is not a mysterious void in the fabric of space, but rather the primordial state of the universe itself, a time before there was starlight. The discovery of this distant emptiness is a powerful confirmation that this dark epoch truly existed. It's the edge of light, it's the shoreline of the cosmic ocean. This confirms the fundamental limit Einstein predicted. We can see the aftermath of the Big Bang, the galaxies, and the light, but we cannot see the event itself. Webb is showing us the horizon he envisioned, a boundary beyond which there is simply no light for a telescope to see. The emptiness Webb found isn't a lack of things, it's the lack of light from a time before light existed. It's the end of our vision. These discoveries are completely reshaping our understanding of cosmology. If you want to continue exploring these incredible new mysteries, make sure you subscribe to join us on this journey of discovery. So, it seems Einstein was right. The absolute beginning of the universe appears to be unobservable, just as his theories implied. But Webb's confirmation of this limit has shattered our understanding of what happened immediately after. The universe didn't just form, it erupted. This leaves us with new, more tantalizing puzzles. The existence of supermassive black holes in the universe's first billion years is a major challenge, as they seem far too massive to have grown so quickly. How did these monsters get so big, so fast? One of the most radical and fascinating ideas to emerge from Webb's data is the potential existence of dark stars. This is a hypothetical object, not powered by nuclear fusion like our Sun, but by the annihilation of dark matter. Theorists propose these dark stars could have grown to be millions of times more massive and billions of times brighter than our Sun, which could explain the impossibly bright objects Webb is seeing. Several candidates identified by Webb seem to match the expected profile of these hypothetical giants. The James Webb Space Telescope was sent to find our cosmic origins. Instead, it found a contradiction, a universe that burst into existence with impossible speed and a boundary wall confirming we may never see the true beginning. We thought we were looking for an answer, but Webb has given us something far more valuable, better questions. And with every image it sends back, our place in this cosmic narrative becomes stranger, more complex, and infinitely more wonderful.